So let's do one last example, and this example is going to be a little bit bigger, but the real purpose of this is to show that you cannot always combine the square roots and the nth roots. You have to make sure that it has the same properties that we were discussing before, where the n is the same value. So go ahead and do the distribution, right? So the first one here, and then the second one out here. So if we write this out, right, it's 3/4 root of p squared plus 1 times the square root of 5p minus 3/4 root of p squared plus 1 times 4/4 root of 2p cubed plus 3p squared. And then do the second one, which is going to be minus 3 square root of 2p plus 1. We don't need that 2. Square root of 5p plus 3 square root of 2p plus 1 times 4. Maybe write down 2. Fourth root of 2p cubed plus 3p squared. Now, the reason why I kept writing those 2's all over the place is because I wrote it up there. And remember, we discussed it a couple of videos ago that you want to make sure that you're copying things straight down. So I'm in a habit of copying, and sometimes when I copy something that doesn't have to be there, it ends up just permeating throughout the entire thing. But so let's look at this problem over here. There are things that we can do, right? We can write this as the 4th root of p squared plus 1 times the square root of 5p. This one, though, we can put together. So we can put minus 12, the 4th root of p squared plus 1 times the inside of the other one. And then the second one here, the second half, we can also throw into a single square root. But the last part we cannot. Now, we do have to go and check this to see if we can factor it. So let's go ahead and do that on the bottom and see what happens. So p squared plus 1 times 2p cubed plus 3p squared is going to equal, let's see, 2p to the 5 plus 3p to the 4 plus 2p cubed plus 3p squared. So this entire thing is this entire distribution. But so far, we don't know how to do factoring with degree 5 and degree 4, degree 3, degree 2, right? The only ones we know which is above 2 is the perfect cube, and the difference in sum of cubes, and when the degree of the polynomial is double the second variable's exponent. So we don't know how to factor this as of right now. So the answer is this horrendous looking expression. So if you cannot do anything with it, you leave it.